Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about complex numbers. Now the question that I've chosen to go through here is 2017 Paper 1 Question 2. In the first part of this question, we're given an Argand grid where the horizontal line represents the real axis and the vertical line represents the imaginary axis. And the complex number Z1 has been plotted on our Argand grid. And we've been told that Z1 can be written in the form of A plus BI. And we've been asked to write down the value of A and the value of B. Now, first of all, you should realise that if a question says write down, it means you don't have to do any work. You should be able to just look at it and tell what the answer is. When a complex number is written in the form of A plus BI, A represents the real value. So to identify the real value, we're just concerned with our horizontal line. Clearly Z1 is in line with 3 relative to our real line. So that means that I know that the real value must be 3. Clearly the imaginary value, if we work across, is minus 1. So that means it must be 3 minus 1i. So Z1 can be written as 3 minus 1i. So to fill this in, your answers are A is equal to 3 and B is equal to minus 1. That's all you needed to write down to get the full marks in the first part of this question. In A part 2 of this question, we're told that Z2 is minus 1 plus 2i. We're asked to plot Z2 on the Argand grid. Well, you should realise that means the real number is minus 1 and the imaginary is 2i. So if we go along the real axis, we go to minus 1 and then we go up to 2. This is where the complex number minus 1 plus 2i is located. So you would label this as Z2 and you get the marks for plotting it there. Directly up from minus 1 and directly across from 2. In A part 3 of this question, we're told that Z3 is Z1 over Z2. We're asked to find Z3 in the form of X plus YI. From the previous parts of the question, we know what Z1 is and we know what Z2 is. So if we sub in, Z3 is just 3 minus 1i over minus 1 plus 2i. Now, you should realise that the problem here is the I on the bottom of the fraction. You need to eliminate the I on the bottom of the fraction. So in the bottom of the fraction I have minus 1 plus 2i. In order to eliminate the I on the bottom of the fraction, you need to multiply this complex number by its conjugate. The conjugate of minus 1 plus 2i is minus 1 minus 2i. Basically it's the same, it's just you change the sign of whatever was in front of the I. So as a plus 2i, it becomes a minus 2i. But I can't just randomly multiply the bottom of a fraction by minus 1 minus 2i. If I multiply the bottom by that, I also have to multiply the top by that. So I have to multiply the top by minus 1 minus 2i as well. Because notice what you're doing now. You're multiplying the top and the bottom, but it's minus 1 minus 2i over minus 1 minus 2i. If you do the same thing on the top and the bottom of the fraction, it only has a value of 1. So I'm just multiplying by 1. I'm not actually changing the value of the expression. Now, you need to realise that at the top of the fraction you have 3 minus 1i times minus 1 minus 2i. In order to simplify that, it's double brackets. You're going to have to multiply it out as double brackets. The same on the bottom. I have minus 1 plus 2i times minus 1 minus 2i. I'm going to have to multiply that out as double brackets. So for the moment, let's just worry about the top line. The top of the fraction, I have 3 minus 1i multiplied by minus 1 minus 2i. Now, in order to multiply out double brackets, you have to take the first thing in the first bracket and multiply it by the second bracket. And then take the second thing in the first bracket and multiply it by the second bracket. So this is how I'm going to expand it. Plus 3 by minus 1 gives me minus 3. Plus 3 by minus 2i gives me minus 6i. Minus 1i multiplied by minus 1 gives me plus 1i. And then minus 1i multiplied by minus 2i gives me plus 2i squared. Now we can group a lot of like terms here, but you need to be careful. You've got minus 3. Now you need to realise that this is 2. Remember, when you're dealing with complex numbers, I squared is minus 1. So I'm going to write this term beside the 3. It's plus 2, but instead of an I squared, I can sub in minus 1. So instead of plus 2i squared, it's just plus 2 by minus 1. And then I can group these together. Minus 6i plus 1i, they're like terms, so I can add them. Minus 6i plus 1i becomes just minus 5i. Now let's just simplify this further. Minus 3 and then plus 2 by minus 1 is minus 2, and that's just a minus 5i. Which means obviously now I can group my two like terms. Minus 3 minus 2 is minus 5 minus 5i. So the top of this fraction simplifies fully. When you multiply 3 minus 1i by minus 1 minus 2i, it simplifies fully to minus 5 minus 5i. Now, the next thing we need to do is we need to multiply the bottoms by each other. We need to multiply minus 1 plus 2i by minus 1 minus 2i. So let's continue that on here. The bottom of the fraction, I have minus 1 plus 2i multiplied by minus 1 minus 2i. In order to multiply double brackets, it's the first thing by the second bracket and then the second thing by the second bracket. So it's going to be minus 1 multiplied by minus 1 minus 2i. And then the second thing in the first bracket is plus 2i multiplied by the second bracket, which is minus 1 minus 2i. And now I can just multiply it out. Minus 1 multiplied by minus 1 is plus 1. Minus 1 multiplied by minus 2i gives me plus 2i. Plus 2i multiplied by minus 1 is minus 2i. And then plus 2i multiplied by minus 2i gives me minus 4i squared. Now you remember what I said at the very start. We wanted to get rid of the I on the bottom of the fraction. In order to get rid of the I on the bottom of the fraction, we're multiplying this by its conjugate. Because whenever you multiply something by its conjugate, the two middle terms always cancel each other out. This is plus 2i minus 2i, which is just 0, so it cancels. So they're actually gone. And I'm just left with 1, the first term, and the last term, which is minus 4. Instead of I squared, I can sub in a minus 1. So if we simplify this further, minus 4 by minus 1 is plus 4. Which means simplified fully, this just works out as 5. So if you multiply minus 1 plus 2i by minus 1 minus 2i, you just get 5. And that means the bottom of the fraction just simplifies to 5. So obviously I think you would, in this question in the exam, you'd have the main body, where this is all you have to write down, but in rough work along the side you'd have your double brackets and you'd have everything multiplied out. Now I can divide 5 into each of these. 5 into minus 5 is going to go minus 1 times. And 5 into minus 5i is going to go minus I times. So your final answer for that one is just minus 1 minus 1i. Okay, for the final part of this question, we were given a linear equation with a z in it. And we've been asked to find the value of z. So we just need to multiply this out, simplify it, and end up with z on its own. So what I did here was I multiplied minus 6 by 4 is minus 24. Minus 6 by minus 6i is plus 36i. Then I multiply out these double brackets. And in order to do that, it's the first thing in the first bracket by the second bracket, then the second thing in the first bracket by the second bracket. In other words, minus 1 times 4 minus 2i plus I times 4 minus 2i. When I multiply that out, minus 1 by 4 is minus 4. Minus 1 by minus 2i is plus 2i. Plus I by plus 4 is plus 4i. And plus I by minus 2i is minus 2i squared. And now instead of an I squared, I can sub in a minus 1. So all I did on this line was I added 2i plus 4i adds up to 6i. And I have minus 2 minus 1 instead of minus 2i squared. I decided to I had a minus 24 and a plus 36i on the left hand side, and I decided to isolate my z. So I add 24 to both sides and I end up with a plus 24 on the right hand side. I had a plus 36i on the left, so I subtracted 36i from both sides and I end up with a minus 36i on the right. On this line I've still leaving my 2z on its own on the left, and I'm just grouping the real numbers. I have a 24, I have a minus 4, and minus 2 multiplied by minus 1 adds up to plus 2. And then if I group the i's, I have a minus 36i and a plus 6i. So now all I have to do is group the like terms. Or I'll add the like terms together. 24 minus 4 plus 2 is 22. Minus 36 plus 6 is minus 30i. If 2z equals 22 minus 30i, I just divide both sides by 2. If I divide both sides by 2, I end up with z equals 11 minus 15i. And that's your final answer for this part of the question. Now I hope all of that makes sense. If there's anything you're struggling with there or you'd like me to explain differently, just let me know in class or send me an email and I'll go through it with you.